Okay, now let us look quickly how this particular tool works. Yeah, the CodeQuest Academy, the tool which helps children learn how to program. So it has got two features. We have the Codey and the Tutor. So when we look at the tutor, meaning we are looking at people including parents, teachers, and many others. Then when we look at the Codey, it's a child itself. So there's a message that prompts from the robot to say, "Hi, I am Codey. To teach, to reach the battery, I need to move forward." So you can be able to analyze this tip. So analyzing this tip, it will even give you to say, drag the move block into the workspace to tell me what to do. So you are dragging it here. In short, if you want, you can just pick it up to down there. If you want, you can click it. So the other feature that is there are the levels. We have these levels moving up to the other level, up to level 30. Up to level 30. On the other side, we have the teen academy, where it shows the syllabus and some quizzes that are there. So with the syllabus, it helps you explain what you are doing in this particular level. So when you look at level 1, the syllabus tells you to say the logic and sequence you are using. It teaches you that computers execute instructions sequentially from top to the bottom. Then order is very much critical in programming. So without proper order, your program will be just something else. So changing the order or coordinates or turning commands completely alters what? The terminal outcome. So this needs to be well understood in a child to say the logic behind the execution of instruction for a computer is a step-by-step process from top to down. Then once I change something, I change the coordinates, I change the order and the flow of things, meaning the outcome will be different. Then on the other hand, under this level, we are looking at the Codey itself. Under this level, we find another tool which is in the syllabus. We find loops and drive principles. So when you talk about loops and drive principles, what are these? These are simply tools that developers use in order to create instruction matrix. So in this particular game, writing the exact same command makes in this particular game, the child understands it clearly to say writing the exact same command 10 times is redundant. So they will now learn to say, the developers, they use loops to bundle instructions together. So this saves a lot of things. It saves the space, which is the storage itself. It also keeps algorithms extremely easy to upgrade. Then the next level, a child will learn to say branching logics or conditions are important. What are some of those that they will learn? You know, children will even understand to say software survives on adaptation. Most of us, we learned that when we are in college and university, to say these softwares, they survive on adaptation. So programmers write if or else conditions or codes to do the issues of filters. When you want to filter something, you use if or else. I'm sure parents will be able to remember in the what subject, what program is that? Excel? Yeah, somewhere like that. Then to evaluate something, they use true or false predictions. Yeah. So if in this particular game, in this level, that's what children will learn. Then they'll also be able, giving an example, maybe they'll be able to assess the block boundaries, to say, oh no, here the block is not supposed to move. When you look at it here, it's just clear. You can move anywhere. But you find that learners or children will learn to say, oh, where there's an X, it's a boundary, it's not supposed to go there. Colored marks another thing, then level targets also is another thing. The other thing that children will learn in this level is that they will learn the issue of state management. So the robot itself has temporary memory database for storing coordinates. It's there to store those coordinates, and collection itself in this particular tool is robot to inventory. So meaning programs query variables are what? Recursively. They are recursively, meaning they flow in a certain format, and their state management is very much stable. There will be nothing like, oh, this or that. No. So on the other hand, there is a part where whatever the child is doing, the syntax is translated. So the syntax translator is the one that is here. So we have Python translator, then we have also JavaScript translator. So you can even, a child can even copy this and take it to what? And take it to another level. Or take it to, what's this, in any code editor. So now let's just do this game as a demo. So we are moving the block. So when we get as I just forgot one thing here. There's a logic quiz. So there's a logic quiz that is given. So if the robot starts at fetching east, turns left, then forward once on the grid, which direction did it go? Then you can be able to answer the quiz. Example, you can say, okay, it starts facing, the robot starts at facing east, turns left, then moves forward on the grid. Which direction is it going? Facing east, turns left, it's facing east, then turns left, moves forward once on the grid. Then which direction will it take? Okay, I'll use my own, let's say it goes to the north. Then let's see, we compare. Perfect, 100%. So turning left from east makes the robot face north, so moving forward takes northwards. That is just like a quiz which is there. So the quiz keeps flowing. There are so many questions that you can practice. You can go to the next quiz. Then let's just go back to our game. So this game is entirely a coding game. So these coding blocks can be moved. This is our robot here. It needs to go to the battery. It's fetching for the battery. Here's the objective. Target, help the robot reach the battery. So here you say you drag or drop. So you can easily move and drop it down there. If this drag and drop fails, you can just click move forward. Then the block will move forward. Let's start again. Move forward. The block will go forward. Then again move forward. It will reach there. Then run the program. Automatically, boom. And the program, great job, you reached the battery. That is perfect. So you got the next level. Automatically here to change to another level. So we have this, we are getting to the battery. So where do we move now? We can't move forward. We need to turn, which is right. It turns right. Then it moves forward. Again turns right. Let's see. So you say turn right, then move forward, turn right, again. Oh no, made a mistake. All right, let's see how it goes. So even if you make that such a mistake, you can be able to delete. You can be able to delete. If path ahead, okay, then then let's do this. Let's try this. Let's move on. Oops, that's failed. So it turned right, failed, turned right, move forward, turn right, move forward, that's failed. So we can be able to try again. So we say turn, move forward. Let me just delete those options that we had put. So now we say move, no, turn right, then move forward, move forward. Let's see. So here, whatever you have clicked is defined in Python here. This is Python. When you take it to JS or to JavaScript, it will also be there. Then also now execute. We see how it moves. Oh no, fails again. So this is how basically it will work. It will keep on improving, going until the other level. Thank you very much for your time, and see you then.